Well, fellas, we're into the new model season once again, and I know you'll want to hear the latest. So I've got Bob and Joe primed and ready to give you a roundup of the servicing highlights for 1970. Bob, you're the leadoff man. Tell us what you know about the new ones.
Okay, Tech. For an opener, we can start with some of the body features common to the new Barracuda and Challenger models. Except for styling details, the body structure of both models is generally the same as in our other cars. But you'll find that new collision protection features have been added. For example, there's a strong two-piece channel section beam welded into each door to give extra protection against side impact. Also, the lock pillars and strikers have additional reinforcements to resist accidental door opening in a collision. There are box section support structures built into both sides of the rear roof area to give more rollover protection. Along with this, the windshield header and roof rails are fully boxed to further strengthen the roof structure. The new flush-mounted outside door handle operates by lifting up and out to provide greater protection against accidental door opening. The door lock cylinder is located next to the lift handle and can be serviced through a hole in the inside door panel under the trim. On the inside, you'll find the door lock control located in the hand grip recess of the armrest. This new toggle lever control is convenient for the driver and passenger, but the location makes attempts at theft more difficult. A conventional link rod connects the toggle lever to the door lock.
Thank you, Bob. By this time, all you technicians should be familiar with a special wrench needed to adjust the door latch striker. So we'll let it go at that and move on to the steering columns. Ready to go, Joe?
All ready, Tech. Starting again with the Barracuda and Challenger models, we've got a brand new steering column with a corrugated impact-absorbing member at the upper end. The corrugations fold one by one to absorb impact energy. Actually, servicing the new steering column is simpler because the impact member is at the top, above the gear selector lever. While this design still requires an impact-absorbing steering shaft, it uses a solid gear selector tube and a solid mounting bracket. In other words, if the upper member is collapsed, but lower steering column parts are not damaged, you can replace the upper members separately. Of course, with complete or partial collapse, the steering shaft telescopes and must be replaced to restore its energy-absorbing characteristics. As for removal, 3 stud nuts attach the steering wheel to the top of the collapsible member. When the wheel is off, you'll notice that the hub at the bottom has 2 tapped holes, so you can use a steering wheel puller to remove the member from the steering shaft. Now, moving on to other features, all models now have a combined steering wheel lock and ignition switch located on the right-hand side of the steering column. As you probably know, the wheel cannot be turned when the key is either in lock or accessory position. The steering wheel can only be locked when the torque flight selector lever is in park, or the manual transmission shift lever is in reverse. This arrangement keeps the steering wheel from locking when the car is moving forward. In addition, the key can be removed only when the switch is in lock position. If the key is left in the lock, a buzzer reminds the driver to remove the key when either front door is opened. The locking mechanism in our standard columns is sturdy and simple. Here's how it works. The heart of the lock mechanism is a pivoted 2-piece lock lever and its operating cam. The key cylinder turns the cam to tilt the lock lever in or out of mesh with the gear selector housing and the steering shaft lock plate. Turning the cam also operates the ignition switch. In the locking direction, the cam moves the selector interlock section of the 2-piece lever toward the selector housing wall. This movement spring-loads the steering shaft section of the lever and moves it into mesh with the steering shaft lock plate. If the gear selector lever is not in locking position, a raised surface in the selector housing wall blocks movement of the interlock lever. This blocking action limits the operating cam rotation and keeps the entire mechanism from going into lock position. Cars with a floor mount selector have a separate slave linkage, which moves the column selector housing to the locking position. Remember that adjustment of both the slave and the selector linkage affects steering lock operation. If the adjustment is off, you may not be able to turn the ignition key to the lock position. Now, on columns with a tilt wheel mechanism, the key cylinder turns a toothed sector, which causes a sliding bolt to move in or out of the steering shaft lock plate. The sector also moves a rack and sliding bolt to provide a selector lever lock. On the tilt wheel columns, an actuating rod attached to the rack operates an external ignition switch. Well, that's because these columns don't have space for the internal type switch used on standard columns. As you might expect, steering column changes call for new special tools. There's a new holding fixture for all energy-absorbing columns, old and new. For standard equipment columns, you'll need the new coupling centering gauge, lock plate roll pin tool, and the shaft centering tool. In addition, there's a new lock plate nut socket and a retaining ring installer for tilt columns. And for tilt and telescope columns, the new lock plate compressor makes the job easy. Did I skip anything, Tech?
Well, the shift linkage adjustments of some models are relocated for easier servicing. But we don't have time to cover linkage details right now, so if there's any doubt about adjustments, be sure to check your service manuals. Bob, what's new in the charging system?
All models now have the new electronic voltage regulator. This unit is similar to the earlier model, but the circuit connector is different, so it's not interchangeable. Since these regulators do not have moving parts or adjustments, they are serviced by replacement. A new isolated field alternator is used with the electronic voltage regulator. Both field rotor brushes now have separate connector terminals, and there are corresponding changes in the circuit. As with the voltage regulator, this alternator is not interchangeable with the previous model. The new electronic voltage regulator tester makes charging system checking easy. For either type regulator, you simply plug in the test connector, clip on the ground wire, and plug in the power cord. The test probe is used for alternator output and other voltage checks. And while we're talking about things that make servicing easier, you'll find the new wire terminal removal tool a real time saver when you work on the new pin-type connectors. Press the connector down on the tool to unlock the wire terminal tabs and pull the wire out of the connector block. On Imperials, the outside radio antenna is no more. The antenna now consists of two concealed wires sandwiched in the laminated windshield glass. The wires run upward at center and across the top of the glass to both sides. The antenna connection is located at the center of the windshield base. Also standard on Imperials, the new full-circle horn switch operates when you squeeze the soft strip on the inner surface of the steering wheel rim. Strip contacts in the rim close the circuit when pressed together. This feature is optional on other models. Combined lamp and reflector type body side markers are now used on all models. As on previous models, the lamp housing must be removed for lamp replacement.
Thank you, Bob. That'll keep the electricians busy for a while. Right now, it's time to hear from Joe on air conditioning features.
Okay, Tech. All of our manual-type air conditioning systems now have a new pilot-operated EPR valve. Except for the specs, testing procedure remains the same as before. The valve adjustment is preset and should not be disturbed. As the name suggests, the pilot valve triggers the main valve to make overall EPR valve operation more sensitive and precise. Only the piloted EPR valve can be used in our current air conditioning systems, but replacements for earlier systems can be either the piloted or non-piloted type. In all of our receiver dryers, a high-pressure relief valve now replaces the fusible plug. Instead of a complete discharge and possible loss of compressor oil, this valve vents only the amount of refrigerant needed to restore normal system pressure. A protective plastic disc keeps humidity, dirt, and salt out of the pressure relief valve. For replacement, remove all traces of the damaged disc and apply a new disc cut from adhesive mylar or similar material. Masking or electrical insulation tape should not be used.
And that brings us to the halfway point of our roundup. Joe will continue with the rest of the air conditioning story as soon as someone turns the record. So, relax a bit.
Thank you, Tech. Now, back to air conditioning. All of our receiver dryers also have a low-pressure limit switch, which opens to interrupt the compressor clutch circuit and stop the compressor if system pressure drops below 23 pounds. This protects the compressor against loss of oil and dry run damage if the system is suddenly discharged. A new water valve for our intermediate-size models combines cable and vacuum control. The vacuum actuator overrides the cable control when the off or max AC button is in and stops flow through the heater core. This action reduces condensation on the evaporator surfaces. The water valve for Barracuda and Challenger air conditioning is fully cable controlled. It has the same flow-through and bypass feature as the vacuum-operated valve used on our full-size models. And that about covers the components. We have a brand new air conditioning installation in Barracuda and Challenger models. The main difference is in the evaporator heater assembly, which has 4 direct-acting air door actuators and no linkage adjustments. The internal airflow pattern also differs from other models. Cowl intake air flows through the evaporator to the blower. From there, it passes through the heater core out into the passenger compartment. This flow pattern helps to dry the air and reduces defroster condensation on the windshield.
So much for air conditioning. Bob, we're ready for engine and fuel system features.
Coming right up, Tech. The big news is the 198 cubic inch 6, which is now standard equipment in the Valiant and Dart. This engine is essentially the same as the 225 cubic inch 6, except for shorter crankshaft throw and longer connecting rods. Our 440 high-performance engines and those with 3 two-barrel carburetors now have heavier connecting rods and piston pins, along with a vibration damper and torque converter or flywheel balanced to match. None of these parts can be used separately without upsetting the engine balance. The new hydraulic tappet used in some of our 1970 engines has a larger diameter plunger, so you'll need the new removing and installing tool. This new tool can also be used on previous tappets and does a good job where the tool cannot be aligned with the tappet bore. The 426 Hemi engine now has hydraulic tappets. This results in a quieter engine and reduced maintenance. There are other design and material improvements in our 1970 engines, but we've covered the major changes, so now we can go on to fuel system features. First of all, there's a new Holley two-barrel carburetor for some of our 383 V8 engines. This carburetor has a conventional horizontal float bowl chamber, a vacuum piston-operated power valve, and a plunger-type accelerating pump. Servicing details and specs are in the service manuals. A new feature of this carburetor is the switch for the distributor retard solenoid. The curb idle adjusting screw acts as the ground contact of this switch, completing the circuit when the throttle closes. We'll get into details of the solenoid farther on. Incidentally, when you service this carburetor, remember that the idle tubes are pressed in and can be bent or damaged if the air horn is not handled carefully. To remove the self-sealing air horn gasket, soak the part in solvent and clean off any fragments with a fiber scraper. Metal scrapers will damage sealing surfaces. The choke side main jet is smaller than its mate by 2 size numbers, so don't get them switched. And for power valve service, be sure to use a wide blade tool with a center relief slot to avoid valve stem damage. Now, as for exhaust emissions. Several changes in our 1970 models improve emission control and drivability. Most of our engines now have a heated inlet air system to permit a leaner warm-up mixture. In effect, this system reduces the amount of choking needed for good warm-up drivability. Here's how it works. If temperature in the carburetor air cleaner is below 100 degrees, direct air intake is blocked by a vacuum-actuated air valve controlled by a thermostat in the air cleaner. Inlet air then comes in through an exhaust manifold stove where it is heated on its way to the air cleaner. When air cleaner temperature rises above 100 degrees, the thermostat and actuator operate to open the air valve. Inlet air now enters the air cleaner directly without being preheated. Also in the emission control department, we have a throttle stop solenoid on our high-performance engines. It maintains the relatively high idle speed needed to hold emissions down during idle and deceleration. The solenoid plunger retracts when the ignition is switched off. This allows more complete throttle closing to prevent after running. The throttle stop solenoid on our standard 440 V8 also includes a switch contact for the timing retard solenoid. As on the new Holley two-barrel carburetor, the ground contact of this switch is the curb idle speed adjusting screw. All of our 383 and 440 engines, except the 440 with 3 two-barrel carburetors, have a timing retard solenoid on the distributor vacuum advance assembly. This solenoid retards the timing for emission control at idle without limiting the advance needed for good starting and driving. The 1970 Chrysler Corporation cars sold in California have a new evaporation control system with a vapor liquid separator. This is a closed venting system for the carburetor and fuel tank, which reduces the loss of fuel vapor. The basic system is quite simple and requires no regular maintenance. Fuel vapor from the carburetor float bowl passes through a vent line to the crankcase air cleaner and settles in the crankcase. When the engine is running, the vapors are purged from the crankcase and intake manifold by the crankcase ventilation system. The fuel tank vent line also leads to the crankcase air cleaner. To keep liquid fuel out of the tank vent line, a vapor liquid separator traps any liquid coming from the tank vents and returns it to the tank. The tank filler tube has a sealed cap.
Okay, Bob, take a breather. Joe can add the finishing touches to our roundup. Right, Joe?
Right, Tech. And first in line, we have a brand new 3-speed manual transmission with all forward speeds synchronized, eliminating the need for the previously used clutch interlock. Shift forks and the shift interlock are located in the housing cover for easier servicing. All gears, including reverse, are in constant mesh. In shifts, the synchronizer ring picks up the desired gear and brings it up to speed. Synchronizer spline teeth block gear engagement until rotating speeds are equalized. Incidentally, the counter shaft in this job is longer, so you'll need the new shaft bearing arbor. The new interlock mechanism uses a pair of notched, spring-loaded levers to prevent selecting 2 gears at the same time. When shifting, the over-center spring and lever cam action assists the shift. And that brings us to brakes. The floating caliper disc brake is now standard on Imperials and optional on all other models except Valiant and Dart. Brake servicing procedures are the same as on previous models. Before machining a floating caliper brake disc, use the new thickness checking gauge to determine how much material can be safely removed from each side. The extended side of the gauge plate is for checking discs of full-size models. The recessed side is for the intermediates. Now, to make the check, put the gauge ball in the inner bearing cup and the gauge plate over the ball's center so you can check the clearance with a feeler gauge. As an example, let's say it measures 20 thousandths. This is the amount of material you can remove from the inner disc surface. Next, mic the disc. And for our example, assume that we get a reading of 1.245. From this measurement, we subtract the 1.200 minimum thickness limit specified for these models and get a 0.045 total removal limit. Now, to determine the outer disc surface limit, take the 0.045 total limit figure and subtract the 20 thousandth inner surface removal limit that we got with the ball and gauge plate. This leaves a 0.025 removal limit for the outer surface. Now, besides disc servicing, when you bleed these floating caliper disc brakes with a pressure tank, the plunger and the new metering valve must be held out to keep the valve from operating. simply compress the brake bleeding tool and engage it in the push rod groove. Never, and I repeat, never forget to remove the tool when you're finished. Rear axle servicing is the wrap-up for our story. Here we are mostly concerned with new special tools since servicing procedures are unchanged. This tool layout tells the story better than words, so I'll stop my speech right here.
Thank you, Joe and Bob, for an informative session on 1970 model service highlights. Right now is a good time to grab those reference books and service manuals for a follow-through where we couldn't give you all the details. And as a special sign-off announcement, be sure to attend the next meeting so you can see yours truly and the crew in living color.